Okay, ma? So the next concept which we are studying is force of buoyancy. So what is meant by force of buoyancy on any body which is present inside any fluid or any liquid also? Liquids or fluids always exert an upward force. Clear? So the net upward force acting on any body is called as force of buoyancy. Okay? And what is the reason for this force of buoyancy? Let us write down. So reason for force of buoyancy is pressure differences between top and bottom of body. Okay? Now let us take an example and let us try to understand why this force of buoyancy is acting. Okay, Seema, let us take. So this is a container in which water is present and this is a body. Okay, ma? So it is present inside this water. Okay. So the top surface of this body, it is at a height of h1. Okay. And the bottom surface of this body, it is present at a height of h2. Are you able to understand, ma? Top surface is present at a height of h1. Bottom surface is present at a height of h2. So therefore, here the pressure acting on the top surface is P1, on the bottom surface the pressure acting is P2. So can you say how much will be the pressure which is acting on the top surface, ma? P1 will be how much? So P1 will be P atmosphere plus, and this is at what height? It is at a depth of rho hg, no? So rho h1 into g. That is the pressure acting on the topmost surface. Similarly, what is the pressure acting on the bottommost surface? It is also P atmosphere plus rho into h2 into g. Clear, no? So therefore, which pressure is greater? P1 is greater than P2 or P2 is greater than P1? Definitely P2 is greater than P1. So P2 is greater than P1. Are you able to understand? Similarly, the force which is acting on the top surface, if I take that body here, okay, ma? So force due to pressure, it is acting in this direction, no? This force is F1. And here also there will be some force acting. This force, let us call it as F2. And here also there will be one force acting, let us call it as F3. And here also there will be one force acting, I can call it as F4. Okay? So F2 and F3, can I say they are equal? F2 and F3, they are equal. Why? Because these two forces are acting at same height, no, ma? If a height is same, pressure also will be same. If pressure is same, force also will be same. So one point which I can say is F2 must be equal to F3 because they are at the same height. So therefore, these two forces, they get cancelled with each other because they are equal and opposite. Are you able to understand? So therefore, what I say, F2 and F3 are equal and opposite. Okay? So what happens? So they get cancelled with each other. They get cancelled with each other. Are you able to understand, ma, what is happening? But what is the relation between F1 and F4? Are they equal, ma? Relation between F1 and F4, are they equal? No. So which one is bigger than which one? F4 is bigger than F1. Why? What is the reason? Because here pressure is greater, no? At the bottommost surface, pressure is greater. If pressure is greater, pressure is nothing but force per unit area, no? Pressure is nothing but force per unit area. If pressure is greater, definitely force applied is also greater. So definitely F4 is greater than F1. Is it clear? So therefore we write F4 is greater than F1. Okay? It means that on this body, bottom force is greater than topmost force. So this is F1 and this force is F4. Clear? I am drawing by a bigger vector. F1 is a very small vector, F4 is a bigger vector. So therefore, what is the net force in vertical direction? Net force in a vertical direction is how much? In vertical direction, net force is how much? F4 minus F1. Okay, ma? Therefore, F net is how much? F4 minus F1. And this net force will be in which direction? Upwards direction or downwards direction? Upwards direction. Clear, Nama? Because F4 is bigger than F1, no? So net force will be in upward direction. So that net force is exactly what is called as force of buoyancy. Are you able to understand, ma? So therefore, this net force I can call it as FB, force of buoyancy. Are you able to understand? So therefore, on any body, always there will be an upward force. Okay? And that upward force is exactly what is called as force of buoyancy. And what is the reason for this upward force? Pressure differences are the reason, no? On the top surface there is one pressure, on the bottom surface there is one more pressure. And these pressures, they are not equal. Okay? If pressures are not equal, forces also, they are not equal. So therefore, bottom force is greater than topmost force. And forces always act in which direction? Perpendicular to contact surface. So this is the direction of topmost force, this is the direction of bottommost force. So F4 is greater than F1, and if you take the resultant of those two, that is the force of buoyancy. Is it clear? Right. Okay, but see here. So next concept is Archimedes Principle. So Archimedes Principle says that the force of buoyancy acting on any body is exactly equal to the weight of the liquid displaced by that particular body. Are you able to understand, ma? So appears like a very simple statement, ma, but there is a lot of meaning in this one. See, ma. So here I have taken two bodies, ma. This is first body and this is second body. Clear, no? So this second body, it is completely immersed in this liquid, no? Second body is completely immersed, whereas first body is only partially immersed in this liquid. Are you able to understand, ma? So what is meant by force of buoyancy? He says that force of buoyancy acting on any body is exactly equal to the weight of liquid displaced by that particular body. Displaced by body. Are you able to understand, ma? So this body, if I immerse this one inside a liquid, it will displace some liquid, no? If that body should go inside liquid, it should separate some water, no? It should displace some water from its position. So if you take the weight of that displaced liquid, and displaced by which body? The body on which you are checking the force of buoyancy. And you take the weight of that liquid, then that weight is exactly equal to force of buoyancy. Is it clear? So force of buoyancy, it is always an upward force, no? So that upward force acting on a body is exactly equal to, you have to take weight of the liquid. Weight of which liquid? Weight of the liquid which is displaced by this body. Not mass. Mass of the liquid you should not take. You should take weight of the body. Weight of the liquid. It means mass multiplied by G value will give weight of the liquid. That's all. So that weight is nothing but force of buoyancy. Now let us do some more calculation. So force of buoyancy can be written as, weight can be written as mg, no ma? Weight can be written as mg. Weight of the liquid which is displaced by this body. Okay. So mass can be again written as density into volume, no? Mass can be written as density into volume multiplied by G value. Is it clear? So therefore, force of buoyancy can be written as rho L. Rho L means what? Density of the liquid which is displaced by this body. And instead of V, I will write VL. VL means what? The volume of liquid which is displaced by this body multiplied by G value. Clear, no? So therefore, this is the formula to calculate force of buoyancy acting on a particular body. Okay, ma? Rho L, VL, G. Rho L means density of liquid displaced, VL means volume of liquid displaced, G means acceleration due to gravity. Is it clear? Okay, ma? Now I will give you a question based on this. Try to do the calculation. Okay, ma? So, a body of mass 2 kg and density 2000 kg per meter cube is completely immersed in water. Second case, this is first case. Second case is half of it is immersed in water. Okay, ma? Then find force of buoyancy in each case. That is the question. Okay, can you do the calculation? Try to do the calculation of this. Okay, Seema, see this question. So in this question we have two conditions now. First one is fully immersed. Okay, ma? Fully immersed condition, and second case is partially immersed condition. Fully immersed means what? So this is a tank of water. Water only, no ma? So in this one, this body is completely immersed, ma. It is completely present inside water. Okay. Now, what is the force of buoyancy formula? Force of buoyancy will be acting in this direction. No, it is always an upward force. Force of buoyancy. So what is the formula for force of buoyancy? Rho L VL G. Okay. Rho L means density of liquid. Density of liquid is 1000. Clear, no? Water only, no? Because water density is 1000. VL is how much? Sima. We know that density is equals to mass by volume. Clear? So therefore volume is equals to how much? Mass by density. This is the formula of volume, no? Density is equal to mass by volume. Volume is equal to mass by density. So what is the mass of the body? 2 kg. Density is how much? 2000. So therefore it is, volume is how much? 1 by 1000 meter cube. This is the volume of the body. Okay. What is this volume? Volume of body. But this body is completely present inside water, no ma? So how much liquid is displaced? This is volume of body. Are you able to understand? Volume formula, mass by density. Are you able to understand what is happening? Volume of body is 1 by 1000. Then what is the volume of liquid displaced? Volume of liquid displaced also 1 by 1000 only, no? Because it is completely immersed. Body is completely immersed. So total volume of the body is inside water. Are you able to understand? So therefore definitely volume of liquid displaced is also how much? Volume of liquid displaced is also volume of the body itself. And it is equal to how much? 1 by 1000 meter cube. Is it clear, ma? Now can't you calculate force of buoyancy? What is the formula for force of buoyancy? Force of buoyancy is rho L VL into G. Okay, ma? So in first case I am calculating. So force of buoyancy is how much? It is rho L VL G. Density of liquid is 1000. Volume is 1000. G value is 10. So total how much, ma? 10. So 10 Newton is the force of buoyancy acting on this body. Is it clear? Have you understood, ma? Okay. Now let us go for the second condition. Second condition is what? Only half of the body is immersed in water. Are you able to understand? Second condition is only half is immersed. So half is immersed means how can I draw the diagram? Okay, ma? So this is a body and only half of the body is present inside the water and half of the body is present outside the water. Is it clear? Now see, again same formula. Force of buoyancy, what is the formula? Rho L VL G. Okay. Density of liquid is 1000. And how much volume is present inside water? Only half. So it is a half of 1 by 1000 multiplied by G value is 10. Is it clear, ma? VL means what? VL means, we should observe very carefully, ma. VL means what? VL is not volume of the body. VL is volume of liquid displaced by the body. Only half of the body is immersed, no? So only half of the volume it will displace. Displace cheyadam ante pakkaku jarapadam ani artham. Is it clear? So therefore it is exactly half of 10 Newton nama. So answer is 5 Newton. That's my answer. Is it clear? That's it. So next we are studying about principle of flotation, ma. So see here. So case number 1. Case number 1 is, let us consider weight of the body is greater than force of buoyancy. Clear, nama? See, ma, on a body present inside liquid, two forces are always acting. No? One is weight of the body. Its own weight. Weight mg is always acting downwards, nama. And because of fluid, force of buoyancy is always acting in upward direction. So on this body, always two forces will be acting. Weight, which is always pulling the body downwards. Force of buoyancy, which is always pulling the body in upward direction. Now see. So if weight is greater than force of buoyancy, then can you say what will happen? Body will sink. That's all. No? So if weight is greater than force of buoyancy, body will sink. It will go downwards. Clear, no? Now what is this W, ma? W means what? Weight of body. It is not weight of liquid, ma. Weight of body. Weight of body formula mg, no? Mass can be written as density into volume into g, no? So density means density of body, volume means volume of body multiplied by g. Are you able to understand, ma, what is happening? Clear, no? Similarly, what is the formula for force of buoyancy? It is rho L VL g. Rho L means density of liquid, VL means volume of liquid displaced, g means acceleration due to gravity. Okay, so therefore what I write? So this is the condition which I am taking, no? So rho body V body multiplied by g is greater than rho L VL g. Okay, are you able to understand? Weight is weight of body, rho density of body, V volume of body. Rho L density of liquid, VL is volume of liquid displaced. Arthamautunnayi the conditions. Okay. Now see, my body is completely present inside water, no? Body is present completely inside water. So therefore can I say volume of body and volume of liquid displaced both will be equal? Body ki anta volume untundo ante liquid displaced kuda ayi untundi. Both are equal, no? If both are equal, why don't you cancel them? Na? G and G also you can cancel them, no? So what is the conclusion I got? Density of body is greater than density of liquid. Is it clear? Okay. So the body will sink in which condition? Body will sink only when density of body is greater than density of liquid. Is it clear? In which condition a body will sink? ఏ కండిషన్లో బాడీస్ సింక్ అవుతాయి? When density of those bodies is greater than density of liquid. So if I place this pen on water, will it float or will it sink? How can you say? Doesn't depend on weight. అదే 14 సార్లు చెప్తున్నది. ఏదో సుబ్బారావు సుబ్బక్కలాగా వింటా ఉన్నారు మీరు. Everything depends on density, doesn't depend on size and mass and weight of the body. Clear, ma? Floating of a body, sinking of a body does not depend on mass, does not depend on weight. It depends only on density of this body. If density of this pen is greater than density of water, it will go down. Density of this pen, if it is less than density of water, it will float. Densities, if they are equal, wherever you place the pen will hang there itself. Are you able to understand, ma? So you should have seen ships, no? In USA and in big in eastern western countries, you will find very, very big ships. Ships 2 times bigger than Titanic, 3 times bigger than Titanic. This kind of ships you can find. And ship is completely made up of metal. Ship is mostly made up of metal. But still they are floating on water, no? What is the reason? So their shape is made such that overall density of the ship is less than density of water. Okay, ma? Whenever you can make bodies such that their density is less than density of liquid, body will float. Otherwise it will sink. You take a 1 rupee coin, put it in water. Will it float or sink? Sink. Why? Density of that coin is greater than density of water. But from the same coin, you make a ship of that coin and you place it on water. Then what happens? It will float. Because overall density now it has reduced. Size has increased, no? Volume has increased, no? When volume increases, density reduces. Automatically it will float. Are you able to understand? That is the concept of principle of flotation. Okay. Now case number 2. Case number 2. Now you can write remaining cases, no? For example, weight of the body is less than force of buoyancy. Weight of this particular body is less than force of buoyancy. Then body will float or sink? Body will float. Body will float. Clear, no? And same condition once again you can write, no? So rho B VB G is less than rho L VL G. So therefore, as it is completely inside, these two get cancelled. So density of body is less than density of liquid. Clear, no? So if density of body is less than density of liquid, body will float. It will come upwards and it starts floating. Clear? Case number 3. What is case number 3? Case number 3 is, clear, ma? So weight of the body and force of buoyancy, they are equal. Both forces, if they are equal, then what happens? Then density of body must be equal to density of liquid. Density of body and density of liquid, both of them, they should be equal. Okay. Then what happens to the body? Then body will hang. Or you can call it as float also. Hang means what? Wherever you place this body, inside liquid or out of liquid, it will stay there itself. Okay, ma? If you take a body and place here, it will stay there only. It will not move upwards, it will not move downwards. Or if you place it on the surface of water, it definitely, it floats. Is it clear, ma, what is happening? So these are the conditions which we have studied. So after studying all these conditions, we will write the law of flotation. Okay, ma? Principles, these are principles of flotation, ma. Now we are writing law of flotation. What is law of flotation? A body will float. A body will float if density of body is less than or equal to density of liquid. That is called as law of flotation. Is it clear, ma? So density of body should be made less than density of liquid, then it can float. Are you able to understand? Let us take one example, ma. See, example is, you take piece of iron. Density of iron is very large when compared to density of water, no? Clear, no, ma? So you take, this is a piece of iron piece, okay, which is a solid piece of iron. Solid piece of iron means what, ma? So inside also iron is present, vacuums are absent. Solid piece of iron, okay. And you put this solid piece of iron on water, what happens? It will immediately, it will sink, it will go to the bottom of the water. Okay. So let us consider its mass is 1 kg, 1 gram, anything. Whatever it may be mass, whatever its size is, definitely it will sink. Now by using the same iron piece, I will make a box. Are you able to understand? Same iron piece I am taking, 1 kg iron piece, and with that one I am making a box out of it. Box means inside there is no volume. Sorry, inside there is no iron. Oh, you can call it as a shell box. Shell box means what? Mass is not present inside it. Mass is present only on the surface area. Now if I take this one and put it in water, then what happens? Now it starts floating. Why it starts floating? Because its volume has become very big, no? But mass is remaining same. Mass is same 1 kg. This body is also 1 kg body only. Are you able to understand what is the formula of density? Density is equals to mass by volume, no ma? Huh? Mass is same. This is constant. But what is happening to the volume? Volume is becoming very, very, very large. So if denominator increases, what happens to total value? Total value reduces. Clear, no? So if density is made less than water, then this body definitely floats on the surface of water. So this is the principle on which ships are made. Okay, but their shape will be like this, no? Shape of a ship will be like this, no ma? So they will sink only up to here only. If you take the overall volume of this ship and if you take the mass of the ship, then they are made such that their density is less than density of water. Automatically they will float on the surface of water. Are you able to understand me? So this body, if you put here, how it will behave? So happily it will float on the surface of water, even though it is a metal. Is it clear? That's all. So this is called as the principle of flotation. Okay, Sima. So fraction of volume submerged of a floating body. It means in a floating body, how much amount of body is outside water and how much amount of body is present inside water. That fraction I want to calculate. Clear, Nama? Sima, when a body is floating, on this body two forces will be acting, no? What are the two forces? One is own weight of the body and the second one is force of buoyancy. Weight is always in downwards direction, force of buoyancy is always in upwards direction. So if a body is floating, can you say what is the relation between them? Definitely they should be equal. Then only they will float, no? Body is not moving upwards, no? Body is not moving downwards. It is in rest position. It means upward forces and downward forces, they are balanced with each other. So therefore what I can write. So force of buoyancy is equals to weight of this particular body. Okay. Force of buoyancy formula, rho L VL G. Weight of the body, density of body multiplied by volume of the body multiplied by G value. That's all, Nama. Weight formula mg, mass is density into volume. Density of which body? Density of body. Volume means volume of body. G means acceleration due to gravity. Clear, no? So G and G, if I get cancelled, then what is the equation I got? Okay, ma? So let us rearrange this one. V by VB or VL by VB is equals to rho divided by rho L. I can write like this. Okay, ma? Or same relation, if I want to write like this, I can write like this. So V dash by V is equals to rho by rho L. I can write like this. Okay. And what is meant by V dash? V dash is nothing but VL, no ma? Or instead of V dash, you better write to VL only. That is better. VL by V is equals to rho by rho L. Clear, ma? What is VL? Volume of liquid displaced. Volume of liquid displaced is nothing but volume of the body inside water, no? Ante kada. Volume of liquid displaced is because of what? Is because of volume of the body inside the liquid. So VL by V. V means what? Total volume of the body. So this is nothing but a fraction of volume submerged inside water or inside liquid. Clear, Nama? So VL by V is equals to rho by rho L. This is a very, very, very important relation for a floating body, ma. Is it clear? So therefore, VL is nothing but what? VL is nothing but volume of liquid displaced. Or also you can call it as volume of body inside liquid. Okay, so VL by V is what? Fractional volume inside liquid. Okay, ma? So fractional volume inside liquid is how much? Rho divided by rho L. Rho means what? Density of body. Rho L means density of liquid. Is it clear? That's it. Make a note up to here. Sim, I will give you one question. Try to answer that question. Density of ice is 910 kg per meter cube. Okay, ma? So find percentage of ice inside water outside water. This is the question. Okay, ma? So we know that ice floats on the surface of water, no? And density of ice is less than density of water. That is why it is floating. So density of ice is how much? It is approximately 910 kg per meter cube. Then in that condition, I want to calculate how much percentage of ice is inside water and how much percentage is outside water. How can you say? Ela chestar cheppandi. Anybody? So by using this equation, how can I solve? Okay, ma? VL by V is equals to rho by rho L. This is one formula, no? So ice is floating only, no? And for floating bodies, this is the equation. Okay, ma? Now what is VL? VL means what? Volume of ice inside water. Or you can say volume of liquid displaced. And volume of ice inside water. Both are same, no? So water lopala enta ice untundo anta liquid displace ayi untundi ante kada. Is it clear? So he is asking percentage of ice inside water. So definitely you multiply by 100. So VL by V multiplied by 100. Fraction multiplied by 100 converts into percentage, no? That's all. So this is equals to rho by rho L multiplied by 100. Clear, no? But rho means density of ice. Density of ice is how much? 910. Density of liquid is how much? Density of water is 1000 multiplied by 100. So therefore, what are the values which can be cancelled? 1, 2, 3, 1, 2, 3, 1, 2, 3. So 91%. So what do you understand by 91%? 91% of ice is inside water. Only 9% of ice appears to be floating on the water. Are you able to understand, ma? So wherever you go in polar regions, if you see a big ice cube floating on water, you should understand that you are seeing only 9% of ice. And remaining total ice, where it is present inside water. 91% water lopal untundi, ice. Kevalam 9% maatrame paiku untundi. Are you able to understand? So Titanic ship was destroyed only because of this kind of iceberg only. Okay, so diver saw a small hill of ice, very small, this much room bigger size of ice he saw, and he thought that so that is not a small piece of ice, that was a very big piece of ice, because we are seeing only 9% outside water. 91% of ice is inside water. Is it clear? Come on. Similarly, for example, if I give you one more question. Okay, ma? So, write down this question. If 50% of body is floating on water, find the density of body. Can you say how can you do, ma? Find the density of water. Can you say how can you solve this one? 50% of the body is outside water and 50% is inside the water. Sorry, what is the density of body? What is the density of that particular body? Can you say how can I solve it? Ela solve chestam cheppandi. Again I can use same equation, no? So VL by V is equals to rho by rho L. So VL by V multiplied by 100 is nothing but rho by rho L multiplied by 100 percentage. So VL by E is what percentage? Percentage of body inside water. This is confused about the mirror. VL by V indicates a fraction of body inside water, not outside, inside. Okay. So inside how much it is? If floating is 50%, sinking is also 50%. So 50 is equals to rho by rho L multiplied by 100. Clear, Nama? So therefore do the calculation. So density of body is equals to 50 multiplied by density of liquid divided by 100. Okay, ma? So density of liquid is 1000 divided by 100. So how much it is? 500 kg per meter cube. That is the density of this body. Is it clear? Clear, Nama? Correct only, no? So therefore by this experiment what we understand? Okay, ma? If 60% of the body is sinking, then density of that body is 600. Clear, no? This 100. Oh, this is 100, no? 100. Clear, no, ma? So therefore, Sima, if 50% of the body is inside water, its density is 500. Clear? Are you able to understand? 40% of body inside water, its density is 40%. Clear? 20% of body is inside water, density is 20%. Clear? 20% of body is outside water, density of the body is 800. You are supposed to take percentage of body inside water, not outside water. Okay? If 20% is outside, it means how much percentage is inside? 80%. So density of that body will be 80%, 800. This is how you can compare very easily. So 20 questions is there, immediately you can do the calculation. Is it clear, ma? So write down a note point on that one. Okay? So therefore, what is the note point we have to write? Okay, ma? Example, if 20% of body is outside water, we are taking water only, ma. We are not discussing about other liquid. If other liquid is given, this will not work out. Again, you have to use V by VL is VL by V is equals to rho by rho L. For water only, I am saying. For 20% of water is outside water, it means how much percentage is inside, ma? It means 80% is inside water. Therefore, what is its density? So therefore, density of body is 800 kg per meter cube. That is my answer. Clear?